The trees in a certain forest are dying because of an unknown virus. The number of trees surviving 2 years after the onset of the virus is shown in the table below. The relationship between n and t is thought to be of the form n equals ab to the negative t. So we want to put this in straight line form. So let's use logs. So log n is log ab to the negative t. And so log n is equal to log a, take away t log b. You should be getting used enough to this that I don't need to do every line of that now. So we're going to plot log n against t. So we're going to need log n figures here. And this is the form y equals c plus mx, where we can see that the gradient is negative log b. And I'm using a capital B. I should use a small b. Can't mix these things up. And c is equal to log a. Okay, so we're going to need these log figures. So we need log of 2000. That's 3.30. We're going to need log of 1300. Oops. .11. We're going to need log of 890. It's 2.95. Log of 590. .77. Log of 395. .60 and log of 260. .41. And then we want to plot this. So our t values go up to 6. So there's t, 1, 2, 3, 4, 5, 6. And these values go as far as 3.3. So maybe better ways of using this axis, but I'm just going to go 1, 2, 3, 4, 5. And so we've got 1, 3.3. So 1, 2, 3, which is just there. And then we've got 2, 3.11. I'll put there. I've got 3, 2.95, just about there. 4, 2.77, just about there. 5, 2.6, and 6, 2.4. And we want a straight line that goes through those. So let's go like that. And I can see my intercept there is about 3.5. And then if we do a gradient, just take a convenient point like here. You can see that's gone across 6. And it's gone up about 1.1 on this So it might be slightly different on the written solutions, but it's going to be different every time you do it. So the gradient there is negative 1.1 over 6. And let's just leave that as negative 1.1 over 6. That's absolutely fine to leave it like that, I think. So I want to estimate A and B. So the intercept was 3.5. So the intercept was log A, wasn't it? So log A is 3.5. So A would be 10 to the power 3.5. So we'll have 10 to the power 3.5, or 33.5. And that's 3162, we should call that. So 3162. Now, so minus log B was the gradient, and that's minus 1.1 over 6. So we can get rid of those minus signs, and then B is going to be 10 to the 1.1 over 6. So we can work out our value of B. So that's going to be 10 to the power 1.1 divided by 6, which is about 1.53. So if we go back to our equation, it's going to be n equals 3162 multiplied by b to the negative t, so 1.53 to the power negative t. So number of trees surviving after 10 years, we're just going to substitute in 10. And we can calculate that. So that is going to be 3162 multiplied by 1.53 to the power negative 10. That's going to give me 44.9. Let's say that's approximately 45. And number of years until there's 10 trees. So n is 10. So 1.53 to the negative t would be 10 divided by 3162. Take logs of both sides. So it'll be log of this. So drop that down in front. So negative t is going to be log of that over log of that. And so t would be the negative of that. So it's log 10 over 3162 over log 1.53. And so what have we got? We have got log of 10 over 3162 divided by log 1.53, and I forgot the negative, so it'll be 13.53, so let's say 13.5 years.